Hello students, welcome to the course Verilog Hardware Description Language. In the previous video, we discussed regarding the ports, list of ports and declaration of these ports. Okay. So in this video, we'll look at connecting ports. Okay. So how we connect ports to the external signals. Okay. So the different rules, all these things we'll try to cover here. Okay. Port connection rules. One can visualize a port as consisting of two units. Okay. One unit that is internal to the module, okay, and another is external to the module. Okay, so these are two way we will look at the port. Okay, the internal and external units are connected. Okay, so both they are connected. There are rules governing port connections when modules are instantiated within another modules. Okay, so when modules are instantiation, we have learned instantiation, right? So there, so these rules will be followed. The Verilog simulator complains if any port connection rules are violated. Okay, so this is how simulators are built according to these rules. Okay, so if it is violated, it will give through an error. Okay, so the rules are summarized in this figure. So what is meant by this figure? So very simple. Okay, so in when you are writing Verilog program, there are two types of program are there, right? One is design block and stimulus block. Okay, so same way, here the ports internal, external. This is where external, from where wire is connected here, right? So as I told you previously, when I am declaring ports or port, okay. So there are three ports, right? Input and output, and if you have a bidirectional, it is in out. Okay, and always input and in out should be connected as nets. Internally, they should be nets. Okay, so this is what we mentioned. By default, they are net, but output can be explicitly declared as register. That's why output can be register or net. Okay, by default it is net, but you can make it register. But in out and input you could not make it as register. Okay, so this is internal. When it comes to external, okay, so where they will apply, when we are applying stimulus block, we'll make all the inputs as normally registers, right? So inputs as register, output as net. So you have observed maybe in simulation. Okay, so that's why this input can be, by default it is net, explicitly you can declare it as register. Okay, whereas output part it should be net. Okay, similarly in out also should be net. Okay, so I hope something you try to understand from this diagram, okay, about the port connection rules. Okay, so this will normally follow when we write the design block and stimulus block. Okay, so that's why when we are writing design block and when we are declaring ports, input and input we are not any changes. Okay, by default they are wires. Output we can make in the behavioral description, we'll make it as register. Okay, whereas in stimulus block, for inputs we will be assigning register because it should hold a value in case of D flip flop and such cases, right? Whereas output is always wire, it is just driving the output. Okay, so that is what it is summarized here. Clear? So this is what mentioned here. Inputs internally, input port must always you of the type net. Okay, inputs are always internally it is net, that means wire. Externally the inputs can be connected to a variable which is a register or a net. Okay, that is the first one. Similarly output, internally output ports can be of the type register or net. That's whatever figure is there we are trying to explain. Externally output must always be connected to a net, they cannot be connected to a register. Okay, in out internally input in out ports must always be of the type net. Similarly externally also in out port must always be connected to a net, so both it is net in the case of in out. So these are the rules we could not alter and say as it is in the hardware description language manual, so we need to tell. Okay, so this is about the port connection rules. So some more additional points to this port connection rules is width matching. Okay, it is legal to connect internal and external items of different sizes when making inter-module port connections. Okay, however, a warning is typically issued that the widths do not match. Okay, so normally when we are doing HDL lab, you may be working on simulators, right? So there will be different types of errors will come. So if syntax error is there, straight away it will throw the error. But in case if it is a warnings, okay, it will not just it will tell you, but it will proceed with the next calculation. Okay, so same way the width, okay, for example some you have declared as 4-bit, but in the module instantiation you have written it as 3-bit. Okay, so there is a width match, right? So 3-bit and 4-bit, but such cases it is legal in Verilog, but however it will give a warning. Okay, that is called as width matching rule. Okay, so next, unconnected ports. Verilog allows ports to remain unconnected. Okay, so for example, in the full adder we had 3 inputs and 2 outputs, right? So in that one of the output we want only Cout output now, so some we can disconnect it, or if we want some only Cout, we can remain unconnected. That is possible. Certain output port might be simply for debugging, and you might not interested in connecting them to the external signals. Okay, so that's why it will help. You can let a port remain unconnected by instantiating a module as shown below. Okay, the full adder example, 4-bit full adder I have taken with an instance name 0. Sum is the output. Cout, okay, the output port Cout is unconnected here. Okay, so just with a space and comma we have given, the meaning is it is unconnected. That means whatever output comes there we are not interested. Okay, only some output interested, remaining as it is. So this is a rule called as unconnected ports. Okay, so this is about the port connection rules you need to remember. So this is one illegal port connection example. Okay, so here you tell me the already comments are there, you can observe. So module top. Okay, so it is a stimulus module because there is no list of ports. You can come to know it is a stimulus module. So then inputs can be declared output, right? So port declaration can be done it as register, right? So they can be declared as register. So this is valid. Okay, so whereas you could not declare the sum as register. Okay, so it should be a net, right? So this is a problem is there here. This is called as illegal port connection. To correct it, you have to declare it as wire. Okay, whereas output Cout is wire, so there is no problem with this. Okay, so this is the instantiation. So illegal connection because output port sum in module full add 4 is connected to a register variable sum in module. So straight away it will throw an error. Okay, to rectify this, the variable sum is declared at a net. Okay, so just instead of register you have to write wire. Okay, so this is one example. Okay, so how the simulator will throw an error. Second part of this port connection rules is about connecting ports to external signals. Okay, so there are 2 methods of making connections between signals specified in the module instantiation and the ports in a module definition. Okay, so these 2 methods cannot be mixed. So first one is connecting by ordered list, another is connecting ports by name. Okay, so this is the 2 rules we'll be looking into. Okay, connecting by ordered list. First one, connecting by ordered list is the most intuitive method for most beginners. Okay, so that means if you does not mention it by default, the method is ordered list. So far whatever we have done, it is a this intuitive method only, that is ordered list. The signals to be connected must appear in the module instantiation in the same order as the ports in the port list in the module definition. Okay, so just we'll take the same example of a full adder and we'll see how some Cout, ABC in are connected in the instantiation as well as in the design block. Okay, see here, this is the stimulus block. So stimulus block you have declared here the input as register, output as wire. So no problem here. So this is corrected here. Then we have instantiated the full 4-bit full adder with the instance name full add ordered. Okay, and then observe here the first element is output sum, second one is Cout, third one is A, fourth one is B, fifth one is C. Okay, so now connecting by ordered list means when you are writing the module of full add 4, you should write this in the same order. Okay, so that is this ordered list. Hope you are understanding 1 2 3 4 5, the same order, the same number should be there. Okay, you could not change Cout to third position or like that. Okay, see here, this is the design block of the full adder 4 module full add 4. See here, first you have some, there also you had some, second Cout you had, here also you see out. So there you had the capital A, here your small a, small b, and so it is in the order. Okay, names, these are local to this module, that's why it can change. There it is capital, here it is small, so they are both different, but values it will pass, whatever some values it is there, it will be passed there. Okay, or abc in values are there, accordingly it is passed. But in case in this method if you alter here, so this you should be careful only when you are calling instances. Okay, just if you write a simple module, you can write it in any order, nobody will ask you. Okay, but in case if you are using this module in some other module, instantiating it, so then you should be careful about this, using this method. Okay, so if you are having problem with this method, you can have always second method. Okay, so that's the answer. So here output sum, output cout, input, all these internal modules are written, but we are interested in this. Okay, ordered list. Similarly, we'll see the second rule, connecting ports by name. Okay, for large designs where modules have say 50 ports, remembering the order of the ports in the module definition is impractical and error prone. Okay, so for example, in the list of ports in the full adder, you had only 5 ports, right? Only some cout, abc in. Now imagine there is a complex circuit where it is having 50 ports. Okay, for example, your microprocessor chips, whatever coming in today. Okay, so they are almost 40 pins, right? So more pins they have, so then that means that many number of ports. In that case, how you will keep the order? Okay, so you may forgot, so 37, 38, like that, anywhere it can happen the mistake. Okay, so that's why it is impractical and error prone, the first method. Okay, so Verilog provides the capability to connect external signal ports by the port names rather than by position. Ordered list is about position, first position, post position only, whereas this now will have a name. We'll see how to do that. We could connect the ports by name in example above by instantiating the module full add 4 as follows. Note that you can specify the port connections in any order as long as the port name in the module definition correctly matches the external signal. So this is the advantage of this one. So here, since we are giving name, so you can write it in any order, so it will not bother. Okay, so just see the example here, full add 4 with the instance name now, full add by name C here. So dot operators we are using here. Then in the design block, what you are writing cout, that we are writing, and then what is there in stimulus block. Okay, so that we are writing. So this is the order, same way, dot sum, dot b, b. So there we have used small, here capital B, dot c in. Okay, dot a, like that. So we'll be following. Okay, so here you can change the order. See here, b is written first, a is written next, c is order is changed, but it will not give problem because whatever value is there, it will be saved in that only. Okay, so from where, so what you have used in stimulus block and design block, it should be matched here, the name should be matched here, not the position. Okay, so that is about connecting ports by name. So advantages, so one of the advantages, only those ports that are to be connected to external signals must be specified in port connection by name. That means unconnected ports can be dropped, so you can omit that from the connection. For example, if the port cout were to be kept unconnected, the instantiation of full add 4 would look as follows. The port cout is simply dropped from the port list. Okay, so full add 4, full adder by name, dot sum, dot b, b dot c in dot a. So cout is not there here, missing, so it is removed, no comma operator also. Okay, so that is possible in this ports by name. Okay, second advantage, we'll have another advantage of connecting ports by name is that as long as the port name is not changed, the order of ports in the port list of a module can be rearranged without changing the port connections in module instantiations. So that's what I mentioned just now. So in any order you can write when you have written using name. Okay, whereas in ordered list it is not so. Okay, so with this we are completing this short explanation about the connecting ports. Okay, so you had input, output, and note. Okay, so how they should be declared, net and wires, wires or registers. And then we have seen connecting ports to external signals by ordered list and by name. Okay, so in the next video we will be looking at hierarchical name referencing, the last topic. Okay, so if you like this video, so try to click the like button, and also you can share among your batchmates, those who are working in different colleges, if their course is not started yet. Okay, Thank you. We'll see in the next video.